All right, last time we started section 14.2. We're taking a look at area of polygons and circles, although we haven't gotten to circles yet. And we're looking at, I think we're on about page 4, and we're measuring land area. Does that sound right to you guys? The top of that one looks like this one. Okay, so these units are probably less familiar to you than the ones we've done up to now. Who's heard of an acre? Okay, that's good. In what context have you heard about it? Farming, land. Sometimes you'll hear about it in, like when you at some point go to buy houses, or maybe you've been with your parents as they have. If they live in somewhere it's a little bit more rural, they'll even talk about the property that they're purchasing. It's not a farm, but it's still on a bigger piece of property as a specific amount of an acre. So an acre, which does not have an abbreviation, I mean it's only 4 letters, so we're going to give it a buy on that one, is one of the ways that you can measure larger plots of property, and square miles is the other one. And then for metric units, the different ones are air, pronounced or spelled like R, A-R-E, but it's pronounced air, so that's fun, right? Hectare, and those do have abbreviations, A and H-A, and then square kilometers. And there are some unit conversions down here, and you can see, of course, that the metric ones are the top 3. You see base at 10 values, right? Hundreds and thousands and 10,000s and so forth. And the bottom are the fun ones, the acres and the miles, and we have units of conversion that you're less likely to use. You've probably not seen used before, and we won't use them all that much. So 1 acre is 4,840 square yards, and 1 square mile is 640 acres. I do want you to notice something that's very interesting. Do you see everywhere on here where there are squares, like square miles and square kilometers? You see those, right? But do you notice that acres, airs, and hectares are not squared? Okay? They simply are a square measurement. So it's not appropriate to write acres squared. Acres already are squared. That's simply how they're measured. There's no such thing as a linear acre. That's not an appropriate measurement, okay? So that's something to be aware of if you're using any of those, is there's no square units on there. They just are squared. That's what their measurements are given in. Acres, airs, and hectares, yes. And it's basically all of the ones that you see listed here that just don't have a square next to it. Here, here, and here. Right? 1, 2, and 4. All right, so let's do some conversions. This one is a square field, which has a side length of 30 meters, and it wants us to find the area in hectares. So, first of all, notice it didn't give you the area. Did you notice that? It talked about a square field, and it has a side length of 30 meters. So the first thing we actually have to do is to find the area in meters, because we don't know that, or square meters. So if we have the area that we have to find, how do we find the area of this field? Yeah, it's the 30 meters squared, which would give you what? 900 square meters. So that's actually what we're going to be converting, is the 900 square meters. You can set up your picket fence, your railroad tracks, and what we're wanting is we're wanting to turn the square meters into what? Hectares. That's the H-A. Now, normally with our conversions, we do this thing where we move the decimals around and so forth, but gotta be honest, these are conversions that I don't use very often. So I'm probably gonna just set up dimensional analysis, fences, railroad tracks for these problems as well, and use the table that we're given. So here is our hectare right here, and here is the conversion for square meters. So 1 hectare is 10,000 square meters. So here's the 1, and here's my 10,000. Now it's still going to result in an answer that's very nice and pretty. It's going to have a 9 in it and some decimals and zeros potentially. So the answer itself is going to be something that's going to be clean and easy to write. But we're going to use the calculator to go ahead and do that. So we basically end up with, well, actually let me do this first. The square meters cancel, right? And we end up with 900 divided by 10,000. So grab your calculator and let's find out what that numerical value is. Yes. So either 0.09 or just the 0.09. And what are my units? HA for hectares. Okay, that's not so bad, right? Not so bad. Okay, another one. Now we've got a field that has a side of 0.3 miles, and we're going to find the area in square yards. Now this is the English unit, so this is not going to be a pretty answer, and it's not going to have a 3 and a bunch of zeros somewhere. Understand that first off. But we still have to find first the area. So how do I find the area of this particular field? What was it? 0.3 or 0.3? Was it miles? Miles squared. So what is 0.3 squared? Close. Somebody say it. 0.09. .09. Right? Grab your calculator if you're not sure. But there's two decimals. There's one decimal place in each answer, so there's two decimal places in our total answer for the product. 0.9 square miles. Yeah, or miles squared, yes. And we're trying to find it in yards squared. So now I have 0.09 miles squared. Miles squared on bottom. Whoops. Here we go. And I've got my yards squared on top. So, what are the conversion values for that one? It's over here somewhere. Oh, there's a couple of options here. So from this particular table, yes, it looks like we could go from miles into acres and then acres into yards, right? Let's go ahead and do that, and then let's talk through another option in case you were thinking more in terms of conversions that you might already have known in another context. All right, so we're going to do our miles into acres first. So what is the conversion over here from miles and acres? Let's see. 1 square mile to 640 640 acres. So like this, right? And then we need to turn acres into what? Yeah, the yards, the square yards. So it's 1 acre to what? 4,840, right. And of course, the units are canceling, as was the whole idea. Miles are canceling, acres are canceling. And this one has ones only on the bottom, so it works out very nicely. I've got 0.09 times 640 times 4,840. What does that give us? I know y'all have calculators. What do you have? 278,784. Is that right, Emily? Okay. And that's square yards, right? Okay, let me show you one other conversion because I don't want you to always be thinking there's only one right way to do something. I mean, there are occasions when there's at least one simplest way to do something. I know that, but there are often more than one right way to do conversions. You actually know a conversion that converts miles into yards. It was back in section 14.1. So take a look back real quick and tell me what the conversion is from miles, not square or anything, but just miles into yards. That's it. So 1 mile was 1,760 yards. Now I did a conversion kind of like I'm about to do last time. Do you remember what I did next? I squared on the top and the bottom. Because if they're equal, I could simply do this fraction twice, right? And that would be appropriate. So I can actually take the 0.09 times 1760 times 1760, because that's what happens when you square something, and I would get the same value. And the nice thing about this particular one is, if you'll notice, it does it in one step. I didn't have to go through acres to do it, which is kind of friendly. So what do you get if you do that? And I don't really mean like, obviously I know it's the same answer, and hopefully you believe that, but I'd like for you to confirm it with your calculator. Please take your calculator and multiply 0.09 times 1760 times 1760. Is it the same? Good. It should be. So that's good to know. All right, what we're going to do next is we're going to learn some basic area formulas, and I don't really mean learn. We're going to review. You guys know these formulas. The area of a rectangle is Length times width, that's fantastic. We talked a little bit in class last time. It doesn't really matter which one you call which, but typically speaking, we use length to represent the longer of the two and the width to represent the shorter of the two. And sometimes we use the word height instead of width. It doesn't matter. Area of a parallelogram is actually base times height. So this picture, the blue picture on my screen, is a parallelogram. The base is this piece, and it is the exact same as this piece up here from parallelogram from what we've seen before. And height is the perpendicular height. It's not the slanted part. So be careful when you're looking at that you're looking at the right quantities. It's the perpendicular distance. And then of course you recognize the area of a triangle to be 1/2 base times height, which is actually half the area of a parallelogram. And sometimes you think of it as half of the area of a rectangle. They're very similar. Okay, so let's take a look at example 7. Suppose that we know that line L and line AB are parallel. What does that tell us about the areas of triangles ABP, ABQ, ABR, ABS, ABT, and ABU? They're all the same. Why? They have the same base, agreed? All of those triangles, no matter how slanted or straight up and down they are, have the same base and the same height, because the height is the perpendicular distance. And everywhere you measure the distance between these parallel lines perpendicularly, it's going to be the same. Now that's very interesting because when you see slanted triangles, that's a terrible description, but you know what I mean, we often don't think of them as being sort of somehow normal. Every now and then I'll draw a picture like this, and it doesn't matter if I'm talking to my 9-year-old or I'm talking to you guys, somebody will describe this as a what? An upside down triangle. And it's kind of funny because we're the ones who've put this sort of idea that the pointy part's supposed to be at the top. I mean, it's not upside down, it's just drawn the way it's drawn. But these areas are all the same. And you should understand why. The areas are all equal. Because all of these triangles have the same base and height. I mean, not even just like the same, value of it. They have the exact same base, and the height is always being measured the same way, so they have the same base and height. All right, this one you might not have seen before. Has anyone seen the area of a kite before? Nope. An area of a kite is actually 1/2 diameter 1 times diameter 2. I don't mean diameter. Diagonal. That's the word I want. Diagonal 1 times diagonal 2. Remember, diagonals connect non-adjacent vertices. And there's sort of a picture proof, if you will, or a proof by picture of why this works. You can see the picture on the left of the kite, drawn as a kite. And then if you take the triangles and you switch the triangle number 1 down here, and you sort of flip it up into this corner, and you take triangle number 4 and you flip it up into this corner, you end up with a rectangle, right? And you know the area of a rectangle is length times width, and then you can get the same thing happening. Hannah?
So how do you know, because there's a lot of diagonals?
The diagonal always goes. There's not a lot of diagonals. Diagonals connect non-adjacent vertices.
I get what you're saying when you're saying the diagonals. Never mind.
Okay, that's all right. And there are times when your book is not very clear about whether it's measuring a diagonal or a half a diagonal. So if that's not clear to you on a particular problem, feel free to ask, or just pretend that it's one of those and tell me, I'm not sure which one it's supposed to be, so I'm going to pretend like this is measuring the diagonal length and assume that that's the case.
So
that's
on
fine.
that picture, they're pointing out the diagonals they're parallel from.
Right, because it's really difficult to mark D1 right
Yeah.
here and to measure and realize that it's measuring this whole length.
Well, because I was thinking it was doing the outside, and I was like, those aren't diagonals.
They're not diagonals, but they're the same length as the diagonals. Yes, very good point. So you can actually see it really well in this picture, right? Because it's broken apart in such a way that makes it easier to identify. All right, the second one on this screen is the area of a trapezoid. You've probably seen this one before. The area of a trapezoid is actually 1/2 the height times the sum of the bases. And this is okay for it to be written this way. It doesn't hugely bother me, but what it's really doing is it's averaging the base heights. I want you to see this. If you take this 1/2 and this B1 plus B2, all that's doing is getting you an average base, right? Like if you wanted to find the average of your exam 1 and exam 2, you'd add the two tests together and divide by 2. That's what they're doing with these bases. They're adding the two bases together and they're dividing by 2. And then they're multiplying it by the height. And if you think about it like that, it starts to feel a lot more like the rectangle area formula, doesn't it? It's base times height, or length times width. Well, I'm just getting an average length and the width that's constant.
So it's, I don't know if this is a dumb question, but like, so when you do the base 1 plus base 2 and then divided by 2, is that like the exact center? Would that be that?
It would be.
Like,
Yeah, it would be. It would be the length of the exact center. Yeah. And that has a name. It's called the median. All right. I think there's one more on this page. Area formula for a polygon with insides. So the idea is to divide the polygon into incongruent triangles and add up their area. So the picture I've got a hexagon, right? Six sides. It's divided into 6 congruent rectangles. And this has to be regular polygon for this to work, obviously. The height of the congruent triangle is called the apothem. So the area of each of the little triangles is 1/2 the apothem, which is the height, times the side length, which is the base. So they're labeling it in the picture. I know we've got so much language going on, it's like, what are they calling what? Here's your height, right? And here's your base. So the area of a triangle is 1/2 base times height. The base is S and the height is A. And then if you were to add this together, you'd end up with 1/2 AS plus 1/2 AS plus 1/2 AS for however many triangles you have. You'd have a bunch of those added together. They'd all have a 1/2 in them, and they'd all have an A in them, and then they would all have a S in them as well. And so you end up, if you count them all, and you count the S's, what happens if you count all the distances around this object? What do you end up with? The perimeter. So that's where this formula is coming from. Is they're saying, look, we could do that, and we could multiply by 6 because I have 6 triangles and so forth. Or you could have just known the perimeter maybe to start with and the apothem length and done the same thing. This process sounds more complicated than it really ends up being. It looks really weird, but the process of actually doing it's not so bad. Okay? All right. All right, find the area of each of the following figures. Let's just give it a go. All right, this shape is a what? Triangle, which means the area formula for a triangle, which would be what? Base times height divided by 2, or 1/2 base times height. What is the base? 5. What is the height? 3. So what is the area of this triangle? 7.5 meters squared, or square meters, yes. Make sure you have units on everything. The only reason you should not have units is if there's no units in your problem, and that's few and far between. And it's usually a typo on my part if it happens. We'll go with that. What is this an example of? Not a parallelogram. Trapezoid. Parallelogram has 2 sets of parallel sides. The trapezoid doesn't have to have 2. It only has to have 1. And which sides are parallel here? The 10 and the 14. And those then were going to be called our bases. Okay. So my area formula for my trapezoid is 1/2 height times base 1 plus base 2. All right, so what's the height of this parallelogram? Or, you guys did it to me. What's the height of this trapezoid? 7 is right, yes. And what are the bases of this trapezoid? 14 and 10. So, take those values, multiply everything out, add and so forth, and then what do you get? 84 centimeters squared. It's a team effort's right. Okay. What is this? It is a kite. And do you see, Hannah, like when I was talking about before, why it makes it really difficult to know on this one what they're supposed to be identifying? So we're just going to have to make an assumption in the cases when we don't know of what we have. So I'm going to say that the 8 is this whole length. and that the 6 is this whole length. If you decided differently, I'm not going to fault you for it because there's just no way to know the way the picture's drawn, okay? So what is the formula?
1/2
Diagonal 1 times diagonal 2. So 1/2, what are the diagonal 1 and diagonal 2 values? 8 and 6, the way that we've interpreted it anyway. Which is what? 24 square centimeters.